Thank you for that introduction. About a year ago, I was at a code camp, which happens over in Southern Polytech about this time of year. I think it's actually next weekend. And a man who unfortunately I cannot credit gave a really great talk about leap motion and gesture controls. The interweb failed me, and his presentation was no longer online. But it got me back to the point where I'm like, you know, I've had one of those things collecting dust. I need to go play with that. And then I was driving to work, listening to a blog, and heard about React.JS, and had that same thought. Oh, I got to go play with that. Turns out the two work very well together, and we'll go into that towards the end of the talk with some code examples. But basically, I just wanted to start off with the concept of 3D computing, because it's kind of like our hovercraft cars, right? In all of our science, everybody can control and move, and computers can track. But how close are we to getting there in real life? Right now, things seem to be taking off. We're getting a field of choices from all the way up to now Intel is really pushing a RealSense 3D camera with all of their devices. We have the Leap Motion, which we're playing with today, and even some different gesture technologies, such as this Myo armband, which doesn't create a field of cameras, but actually tracks muscle motion and hand position while you're wearing it on your arm. Any other things people know about? So, of course, one of the big questions is, what are these things good for? Well, when you go online, you'll see a lot of kiosk apps, a lot of ad interactive apps, very popular with 3D technologies. Games, of course. Unity engine, you can actually take the Leap Motion, mount it to your Oculus Rift, and then have your hands tracked within game. But there are also some more interesting uses. This one is called a clean room app. So they took the Kinect, they took the Kinect cameras, and for doctors to be able to interact with the computer without having to actually break sterility. Or if you're working in a biolab, for example, and can't get to the computer, you can put it behind a wall, keep it safe and outside of the hot zone, and still be able to interact, search the web, deal with emails and connectivity. This one I love because ever since I saw the first gesture motions, I've wanted sign language, desperately. So this company is going ahead, and they're doing it. They're creating a tablet app that takes a deaf person's sign, translates it into speech for a hearing person to hear, collects the speech back from the hearing person speaking, turns it into text for the deaf person to read, allowing for full round-trip communication. And the future is still growing. We have this little device here from the University of Washington, Seattle. Instead of having to build its own field, instead of all the power controls that it needs to track gestures, this thing knows what your body electrical field is doing within the soup of electronics that we're all around every day. So you could actually, with this thing attached to your phone, keep it in your pocket and control your music just by waving your hand across just beside the phone, through the pants, through a wall, through all sorts of things. This one is kind of cool. They're taking the whole camera, setting up a set of cameras and a projector, and allowing you to have a topographical map in sand. And of course, cars are coming out with it. That's my dream. That's partly why I've been thinking about this so hard as I commute. We all commute in Atlanta. And I hate having to try and get my phone to get Waze to tell me if it's safe to go on 285 or not when I'm trying to listen to Audible or do something else. It'd be nice to be able just to be like, you know, hey phone, time to tell me if it's a new route, right? Well, apparently Volkswagen and BMW are coming out with that very soon in the car. Okay, so at this point, how many people have dust-collecting gesture devices sitting on their shelves right now? Yep. What's the challenge, right? They just are slow. They don't feel natural. We blame the device, but in reality, I think like with any new technology, it's not so much the device as it is the programmers and the application. So let's take a look. Most of these devices, everybody's embracing JavaScript. Every device I've shown has a JavaScript API ready to use. And most of them work the same way. You set up the controller, plug it in with your USB, and it creates a service on your device that as soon as you plug in your client library, it goes out, looks for that particular service, and starts having information fed into it. You write your app around a simple loop, right? So it's constantly feeding you events, you're constantly pulling events and doing whatever you want with the device. And we get into quickly a problem of what I would call big data on a small machine. This is just the hand API. There's a frame API. There's an arm API. Every single one of these fingers, it tracks every single one of these bones. So you've got a large object of data with JSON coming back every single frame that it sends. And so you end up with a lot of, you're suddenly dealing with an app that's dealing with a flood of information. And how do you get through this fast enough to not annoy your users is the trick to making these applications good. So I'll just, to belabor the point, let's do the math, right? Lots of data in a loop continuously processing, and we have done this before and we'll do it again. We end up with waiting apps all the time. This is where Flux and React were actually a nice architectural model to deal with this, because they take away some of the complexity by allowing you that one flow of data. You have an action, the dispatcher manages that, stores manage whatever you're going to hold on to, the view renders it. And so instead of having to code your entire app to fit in the loop, all you have to do is feed your actions in to the dispatcher and then have them pop out to the view. So most people have looked at React, familiar with React at this point? Okay. Okay, so time for fun. Come on, where'd that? 4 fingers? There we go. So basically what I have here is, like I showed in that architecture, right? I just have a simple application. There's a JavaScript in here, there's a client library, and I'm playing with some React views that just demo CSS. This little guy here is actually one of the utilities provided by the LeapMotion thing. It's actually a canvas wrapped. And so we'll hit start to start collecting the data. And as I move my hand across the position, and as long as I stay in sight, then it actually is responding pretty quick to my hand. And the grab strength is measuring as my hand opens and closes. And it can sort of do both at once pretty effectively. And then, of course, the canvas is continuing to track my Y position over the device. Now for what's really cool is how little JavaScript it actually took to write this. So where did we go? Sorry, I expected to have. There we go. Okay, that's big enough. So as I said before, I am using React. This is just a React store. We just, simple import these things. These are all NPM packages. You just download, start a simple, what's the word I want? Require wrapper that React uses. I probably can. No, not going to come bigger, huh? That's what I was just trying. Let's try.
You have it right there.
View. What am I looking for?
View maybe. And then.
Oh, view.
Click.
No. I think it was actually text. Change case. Yeah, I know.
Well, you text display, and there was the first option was something along the lines of show fonts. Maybe that'll show us that font window. Maybe. Set to 24.
Okay.
Oh yeah.
There we go. Okay. We'll do a little scrolling here, but. or not. Quit typing. Okay, so as I said before, you just pull in this controller object. This is what they provide. You give it you can give it some options. One of the key options for a JavaScript app would be to use the setting that has it send you events at the 60 frames per second cycle rate instead of faster. So you're not getting a lot of data you're not going to use anyway. And then you just process the data coming in, decide what you're going to hold on to, and send it out using events. And these events flow through to something like a view. And we'll go here. Come on. Work with me. There we go. And then the nice thing, or maybe one of the controversial bits, but the view just simply doesn't have to do very much. I'm just calculating CSS here. I think this is one of the more controversial aspects of React, is they've stopped going to CSS, and now they're doing what they call inline views, because that way you can control the views with JavaScript. But in the case where you actually want the CSS to change incrementally with every single position of the hand, this is kind of why that's so powerful, because I don't know of a way you could really do that with static CSS. You really do want to be able to calculate it on the fly. And this does a very good job of that. Okay, since I was just the teaser act, I will entertain questions now. I know, Logan, you had a lot of thoughts.
No. So I'll ask the first question.
Sure.
Why did you choose to use ES6 when you wrote this rather than ES5?
Because the GitHub program I started with for the React demo was ES6. Was not really a stylistic choice on my part.
Can you pull up what the where the event looks like when it comes in, or like how you're processing that, all that kind of stuff? I must have missed that.
Okay. I am essentially, where's my loop? Here we go. So this controller on, you can set various things on the controller, start, stop, connect. One of the things you do, instead of doing that leap loop I showed in the other slide, is you can say controller on frame, function frame, set hand. So this is the method that gets called every cycle.
Can you show your set hands?
Sure.
What that's doing?
All this guy's doing.
Or like how you're like what the JSON looks like when it comes to you and
Yeah.
what you're doing.
Yeah. So the set hands is essentially doing nothing more than grabbing what we call the hand list. And I've decided in this case, I was experimenting with different places to put this logic, but I decided to drop it into a store. So that way I can have multiple views react to the same changes in hand information. One of the things with Leap is you always get a frame, but not everything in a frame is valid all the time. And so this, I'm slowly working back towards the idea that I can have, Leap Motion will track up to 4 hands simultaneously. So you could theoretically have different items on the page reacting to different hands. And that's why this is in a store right now, because that way I can query and ask for specific hand items and then deal with the hand API off of each of those.
So it offers continuity between the frames where I can,
yes.
If I have this and then this suddenly comes on the screen, then this becomes hand too.
Exactly. And the controller, you can actually ask historical from the controller as well. So you can ask, the current frame will give you the frame, but you can also ask for a frame ID and be able to query it for the past 10 frames or the past 50 frames, which is really important to something I'm not going to demo tonight. Come to Connect.js. And you'll see one of the powers I have is the gesture controls, right? It can tell not just the position left or right, but it can actually quantify a swipe as opposed to just a slow gradient thing, or a button push as opposed to any other motion, and those are what we call gestures, so they're recognizable actions of the hand that have a distinct beginning and end, and then once they fire, you can attach events to the gesture and avoid having to remap all of the logic about what happened during that frame, or those sets of frames. Oh, yes, you wanted to see the fun of some of the JSON. So, oh yeah, we're over. Wrong one. There we go. We will pull up the joy that is the developer tools. And I think at this point I'm not logging everything, but we will. There we go. So one of the things they say is that when you start dealing with this amount of information, console.log is not actually your friend anymore. But in this case, I have translated the large JSON into a much smaller, just the...
So this is like the first hand,
Yeah, exactly. And that I filtered down. I actually pulled out the position of that from the hand store. I do a convert position here. So I just decide I only want to have to pull down to the hand. And I think that's kind of where I'm playing with it now, is like, how much data do you want to make available? How much of the API is that? Because again, if we go back to the earlier slide, with all of these different devices, each one gives you a lot of the same information, but of course not in the same SDK. Not in the same naming structure, not in the same object structure. So we're kind of getting back to a day that sort of the old school, this is a controller, which means your logic for XYZ or gesture recognition, if you want an app to be able to support multiple of these controllers, you're going to have to partition that out and probably do a lot of internal mapping, but of course, without slowing the app down. So that's going to be one of the challenges I think that we face as we go along. And I don't know if in 5 years, maybe we'll have a unified gesture API that we can reference. But right now, it's a lot of different devices. Everybody's doing their own thing. And so if you're going to target one of these devices, or more than one of these devices, you're really going to have to pay attention to MVC and make sure that the gestures are not embedded into your app, because they will be different on every device.
Let's just say, along those lines, a couple of years ago, we still haven't seen come out of that. Gestural stuff it's going to become mainstream. A lot of these experiments that we've had recently have been less than perfect, but it's coming.
One of the thoughts I've had in my head has always been that accessibility feature of computers. The keyboard and mouse does limit who can use a computer. And obviously, once you start allowing for gestures, especially if you can allow for people to be able to program their own gestures on top of an API for triggers, then theoretically anybody could use a device. If your hands are arthritic or if you've lost your hands, you could still, with this kind of control, be able to set up something that would work very well. And there are lots of people experimenting with that ability. Of course, without a unified API, it makes it hard for app developers to be able to support that yet.
Have you done any experiments with limiting and you would get a higher detail frame rate, right?
So you mean actually telling the controller only give me the first hand, don't give me... Right. Well, it kind of does...
Comes in there.
Yeah. Well, this one, I don't think I can tell it to not send me the other hands, but I just pull off the first hand and only worry about processing data on that one in this particular app. It's just I have visions in my head of being able to do finger puppet theater with more than one kid, so I will be doing more than one hand somehow.
A big problem is speed.
Yeah.
I would think that lowering the number of hands or variables would increase speed. I don't know if you've done
No. No. I haven't pushed it to a limit yet. I haven't locked it up yet. So first we'll do that, and then we'll figure out what we need to do to cut it back.
Have you heard anything about second generation of LeapMotion? Because this is really Gen 1.
Actually, last year, part of what this is they re-released the SDK. Where is? Because the actual. Let's see, do I have my app store? That's the armband manager. Where'd it go? Okay, we'll deal with that later. We can do that one now. When it first came out, it was really clunky, and that was actually because they hadn't finished all the software on it yet. They did a re-release of the entire SDK as well as the controller firmware to give it what they call skeletal tracking. So before it could kind of do large blobs, and now it'll do every single joint and digit all the way back to your mid-elbow, I think, and as a separate individual item it can track. And that was sort of their version 2, was to get to that much higher resolution tracking capability that it actually has. Sure.
You know when you're doing like a combination of 2 devices, you can actually get 3 dimensions instead of just 2 dimensions? You don't know if that?
Yeah, I do, because it is very interesting to watch this thing. You can't, like I tried to do finger puppet theater with it. I'll show you the orientation. If you try to do this, it can't see the top of your hand at all. It really fails on that. I have not seen that yet, except in, strange blogs and people just hacking it. I think, I'm not sure where that one's going to go, how they're going to solve for that problem. I think that the guys who figured out how your hand just sort of sits in the soup of energy might actually be on the right track for that one, because that way they don't have to worry about where the field's coming from. They can actually, they already have the 3-dimensional field to work with. Sure.
What do you enjoy about using React for this specific, like, as opposed to something else?
Well, okay. I'm a Java developer, I'll admit that here and now. So I don't like using JavaScript anyway. I'm doing this on my spare time, and the idea of having to do self-DOM manipulations, I don't have enough energy for that. I did try it with some of the Leap, but that one did it the concept of scope. The time the scope is constantly updating in the 2-way updates, you can crash that app in no time flat. I mean, one little scope update and the thing died. React, it was intuitively easy on how to make sure that things flow through and that the updates were very fast. Their homegrown apps, some of the demo apps, and those once just flew. I was shocked at how well I could do CSS with almost no code. Okay, thank you.
All right, our next speaker came out to visit us from San Francisco. So we appreciate the travel time, and to put us up